So in this question there's a number of triangles that we need to consider. We've got a road and it's cut off in intervals of x, and there's poles that are h meters above the ground there. And then we've got a number of, looking at a point P, we've got some angles of elevation. So we've got a 45 degree one there, 30 degree angle of elevation there. The first part of the question wants us to show that BP is equal to H. Now, if we break down the triangle here, we've got H as the height of the pole. 45 degrees is the angle of elevation, which means this angle here would be 45 as well, which means that must be H as well. It's an isosceles triangle, so then we get H in both of those. For DP is equal to H root 3, well, we consider this triangle that we've got here, the 30, the H, and finding DP. So looking at it there's our DP there, and we want to prove that it's equal to the H root 3. That's going to be used in part 2. So tan 30 is equal to H on DP from our triangle before. It means DP would be H on tan 30. Tan 30 is 1 on root 3. So it would be H on 1 on root 3 gives us the H times root 3. For part 2 of the question, we're saying we're going to use the sine rule on triangle BDP and show the angles 30 degrees. Hence the triangle is right angled at P. So if that's the case, we'll apply the sine rule there. So we've got 60 degrees there, so H root 3 in the sine 60, and the H and theta that we want to use. So sine theta would equal the root 3 on 2, which is the sine 60 over root 3, and the H's would have cancelled. Sine theta is a half, which means theta is 30 degrees, which means we get a right angle triangle with 180 minus the 60 minus the 30 means it's going to be right angled in there. So in part 3 we want to prove that x is equal to 2h. So we can do this a number of ways with this triangle now. Because we've got the angles, we could use trigonometry, or I've just used Pythagoras here and shown with Pythagoras because I know that side's root 3h and that's h, and it's come down to x is equal to 2h. And then by using the cosine rule we want to show that PF is equal to h root 13. So again, getting the triangle there and finding the outside of PF, we know that's 150. We know that's root 3h and 2h. So we just apply the cosine rule. Root minus root 3 on 2 because of cos of 150. Clean it up and with our numbers, and we get 7h squared plus the 6h squared when we clean this up, and gives us 13h squared. Take the square root, gives us root 13h. Then proving that it's the angle that we want of theta is there, so we get the opposite on the hypotenuse, and then take inverse tan of 1 on root 13 and gives us the approximately 15.5 degrees for that angle. So again, we've just used all those triangles. We make sure we get all our triangles correct, then we shouldn't go too far wrong in getting the answers we need.